Homework 6, section 3.4, logical arguments, video number 4. In the previous video, we figured out how to set up a truth table for an argument. Namely, we're going to set up a truth table for the conjunction of the premises pointing to the conclusion. The double-lined arrow is just a conditional. The only reason it has 2 lines instead of 1 is because it's a conditional in the midst of an argument, and it is called an implication. However, it follows the exact same rule as conditional. The only time this is false is when T points to F. Our goal is to see if that implication for this argument is a tautology, and we've already set up the truth table. For details, go watch the previous video, video number 3. All right, let's get this truth table going. When you have 2 simple statements, in this case P and Q, you'll always have 4 rows, because remember, the first 2 columns represent every combination of truth values for the 2 simple statements. Either they're both true, or the first is true and the second is false, or the first is false and the second is true, or both are false. I invite you to pause the video and complete this truth table if you haven't already, because after all, it was set up on the previous video. I'm going to continue, and we're going to finish this truth table. Moving on to the next column, remember, every time you populate a column's truth values, ask yourself 2 questions. What rule am I using, and which previous columns am I applying that rule to? Because this 3rd column for the first connective in our list is a conditional, the rule that we're doing, and I think I'll write the rule down here, is a conditional is false if T points to F. So that's the rule we're going to do. The columns we're going to apply it to are the columns that represent both halves of the conditional, the P and the Q. So we're going to look at these 2 columns, and we want to think about P pointing to Q. So I'm going to go across each row and draw an arrow in the correct direction, P pointing to Q. And now I'm looking to apply this rule. Anywhere I see T pointing to F, I'm going to put false in this column. The only row where T points to F is the 2nd row. So the 2nd row is the only F in this 3rd column. That means the remaining rows in the 3rd column are all true. Well, that was just one of our basic truth tables, the truth table for a conditional. Nothing to look at there. Let's move to the next column. Remember, this next column was set up for the conjunction, so we're going to do the conjunction rule. And the rule for conjunction is it's true only if all true. So that's the rule we're going to apply. But which columns are we going to apply it to? Look on both sides of the conjunction. On the left side is a parentheses, and inside that parentheses is P pointing to Q. So we need the column representing P pointing to Q. That would be the column we just filled in. So let's just point to this column for a moment. And on the right side is just P. So I need this column over here. Unfortunately, there's a column in between the 2 that we're looking at. In a previous video, I did recommend that sometimes you can cross out a column that is in the way, but I wouldn't do that here. Why? Look ahead. I'm going to need the Q column, so I'm going to need to be able to see it. What you can do, especially if you're writing on paper, is just to lay something over any column that you're not looking at for the moment. In this case, I'm going to set this yardstick, maybe, over this Q column so that I literally can't see it. And now, well, maybe, that'll work. Now, I'm going to apply this rule. I'm going to write true only if it's all true to these 2 columns, row by row, starting with the first row. Are these all true? Yes. True goes here. Next row. Are these all true? No. This is not true. Are these all true? No. Are these all true? No. You'll notice I didn't write any F's yet. Focus on one thing at a time. I'm looking for where it's all true, and when I see it, I'm going to write T. Now that I've gone through it, I know what everything else is. False, false, false. And then for the last column, the last column is built for the third connective in the implication. It's essentially a conditional, although technically it's called an implication, but it follows the same rule. So the rule is still F if T points to F. All right? But which columns are we going to apply it to? Well, the left side of this conditional is the big parentheses, which I didn't fill in previously. I think I'll fill it in now. The conditional P pointing to Q, conjunction P. So I need to find a column that represents the contents of this parentheses. That would be the column we just filled in. Double arrow pointing to that column to distinguish it from these. In fact, I can just erase those green arrows. We're focusing on this column. That's what's on the left side of this implication. On the right side is just a Q. That's this column over here. Because we're in the last column, I'm not going to need any other columns besides the two that I'm currently pointing at. There's a column in between them. They're in the way. I'm just going to cross them out. I can also cover it up, but I wanted to remind you when it's okay to cross out a column and when it's not okay. It's okay to cross out a column if you're not going to use it anymore. The only columns I need to calculate this last column's truth values are the second and fourth. The third one was in the way, so it's gone. I guess I could cross out the first column, but it's not really obstructing my view. However, if it helps, don't need that one anymore. So we're going to do this rule to these two columns, but here's where you have to be very careful. Conditional is the only rule where order matters. I need to think about this column pointing to that one. I need to think about the fourth column pointing to the second column. So I'm going to draw my arrows from the fourth column pointing to the second column. You don't have to draw these arrows, but when you're doing a conditional, and when the columns of the conditional are in the reverse order, left and right, right and left, then I would highly recommend drawing the arrows to remind you the direction that you're looking. All right, time to finish. I'm going to play out this rule to the arrows I just drew. I'm going to write F in the last column if I can find any T pointing to any F. So let's start with the first row. T pointing to T. Well, that's not what I'm looking for. F. Well, I'm not looking for that either. I'm looking for T pointing to something. F. F. None of these are T pointing to F, which means that none of these rows are false. Okay, if none of the rows are false, that means that they're all true. The truth table is complete, and now we can answer the question, is it a tautology? Remember, a tautology is a statement that is always true no matter what its simple statements are. In this case, yes, it is a tautology. So the way we can conclude this argument is to say the implication is a tautology. Therefore, the argument is valid. Now, we've lost the context of this argument between the previous video and this one, but just a reminder, the argument we were examining was, if I stay at home, then I will not catch COVID-19. I stay at home, therefore I will not catch COVID-19. So what that means is, if the two premises are true, if the statement, if I stay at home that I won't catch COVID-19 is true, and I stay at home is true, then it must necessarily follow that you would not catch COVID-19. It's quite a lot to go through. Honestly, it's quite a lot to develop, but once you figure out your plan of attack, it is fairly straightforward. In the next video, we'll look at the other argument that I presented initially, which was premise number 1. If I stay at home, then I will not catch COVID-19. Premise number 2, I did not stay at home. Conclusion, therefore I will catch COVID-19. We'll see if that's a valid argument.